Alright, Chapter 4, Neat Modules 9, Part 2. Positive diode clampered with the bias. The bias clamped with the operator with exactly the same energy on bias clamped with one exempt. The exemption is an additional DC bias voltage. They share with the diode resistor with the series side of the polarity of the bias voltage to determine the output clamping for reference. View A, Figure 4.19 illustrates the circuit with the positive clamper with the positive bias. If you identify with the positive clamper with the cathode, the diode is connected with the to this passive. The positive bias can be observed with denoting the negative side of the battery is connected with the ground. The purpose of action with the capacitor resistor for the diode is the same with the unbiased clamper, just as discussed. Show the voltage 10 volt resistor diode capacitor output. The no input with the diode with the forward bias with a 10 positive volt battery with the output with the capacitor. One show with the 10 positive volt hold on the chair. Recharge until the first pulse with the lab of the barrier. Establish the DC reference of the 10 positive volts. The input wave shape shown on top of the view B with the square wave of the alternate 25 volts and negative 25 volts output wave shown at the bottom and half of the view. Here's what the previous chapter. Let's apply with the Kirchhoff voltage law to determine the circuit operational no input with the signal the input. The output just above with the 10 positive volts supplied by the barrier. The time the T0 negative 25 volts applied with the circuit and similarly fell with the cross resistor 1 and diode 1 negative 25 volts input signal forward with the device of DC 1 diode 1 and the capacitor 1 quickly charge the 35 volts leave with the 10 volts for the cross of the output terminal the 4 months of the period of the time 0 to 10 1. Polarity with the charge capacitor is from the left to the right with the minus over the plot at the time 1 with the 35 volts across the capacitor series 8 with the positive 25 volts input signal at the point with the time 1 output voltage become the 60 volt for the voltage across the resistor 1 and the diode 1 is 50 volt for the batteries but 10 volt positive volts. Cathode of the diode 1 is positive with respect to the anoid diode. It does not conduct for the time 1 to 2. Capacitor 1 discharges only slightly through the large resistance of R1 resistor 1. Assume with the side of the resistor 1 capacitor 1 that the capacitor charge with just 2 volts of the 35 volts to 33 volts during this period. The output voltage drop of 60 volts to 58 volts. The T2 time 2 with the negative 25 volts input with the 33 volts of capacitor 1 series output with the mismatch with the voltage cut. The output signal of 8 to 8 volt with the cathode of the diode negative 2 volts with respect with the anode of the diode 1 conducted again sent for the forward by the diode is essentially short with the capacitor 1 quickly charges from 33 volts to 35 volts during the most of the time 1 to time 3. Then we find out with the voltage is 10 volts. Positive 10 volts. The time T3 with the 25 volts input with the signal of the series 8 and 35 volts across the capacitor 1 again. Output the voltage with the 60 volts. So observe at the time 3 with the condition from the circuit the same as they were the time 1. Therefore, the circuit operation from the time 3 to through 4 is the same as with from time 1 and 2. But the circuit operation for the continuous duplication operation, which compared with the time 1 and time 3. By comparing the input-output wave shape with the, you should note that the following peak-to-peak amplitude of the input wave shape that has not been changed with the output with all practical purpose by the action of the clamper circuit with the shape of the input wave that did not change with the output wave shape is not clamped above the 10 volts. Remember the clamping level of 10 volts is determined by the bias battery. The positive diode clampered with a negative bias. The view A figure 420 with the positive clamp with the negative bias with the no input signal with the capacitor charge with the resistor 1 with the bias battery voltage. Output voltage equal to 10 negative 20 volt with the circuit that has negative bias both with the positive side of the battery is ground with the output waveform is shown with the UB with the study with the wave figure with the wave forms carefully. Note the following important points once again with the peak amplitude shape of the output wave with all practical purpose for the sim is the input wave with the lower extremity the output wave that you clamp with the negative 10 volts value with the battery look as circuit operation for the capacitors until the charge is negative 10 volts will be input with no input signal and the diode 1 does not conduct. Figure 428 shows the positive clamper with the negative bias and also the positive clamper with the negative bias in its waveform. The negative 25 volts input signal provide the forward bias with the diode 1 capacitor charge with the 15 volts, about 15 volts retain with the charge to cover the discharge of the resistor 1 and negligible. Positive 25 volts input signal with the series 8 with the capacitor volts with the developed into positive 40 volts between the output terminal with the input volts with the negative 25 volts with the diode 1 conduct with the output volts with the negative 10 volts with the 25 volts plus the 15 volts. In this way, output reference is clamped at the negative 10 volts. The clamping side of the changing the side of the battery, changing the clamping the reference level of the new voltage. Negative diode clamper. The figure 421 view A with the illustrate with the circuit of the negative diode with clamper compared with the reference positive diode clamper. The view A with the figure 418 with the note of the diode reverse the reference with the ground like positive clamper the resistor 1 provide with the discharge path for the capacitor 1. Resistance must be large value for the capacitor 1 to have long discharge time. The low resistance for the diode provided with the faster charge of the path 1. Once capacitor 1 has become the charge of the axis of the source of the voltage, which will help to determine the maximum and minimum voltage level of the output wave shape. The input wave shape of the shown view A and B with the square wave it varies between the 25 volts and negative 25 volts. Output wave shape that is shown in the bottom half of the view B with the wave time with the operation negative clamper is similar to that of the positive clamper except for the reverse polarities. Figures 421 show the negative clamper in waveform. Also show the 421 show the negative clamping waveform, and time 0. Time interval 0, 20 positive 25 volts input signal applied with the circuit across the resistor 1 and diode 1. This make with the anode with the diode 1 positive with respect with the cathode conducts heavily with the diode resistance very small, causing the capacitor 1 charge quickly as the voltage of the capacitor 1 increases the output voltage, decreases the voltage across the capacitor 1 reaches 25 volts during most of the time is interval 0 to 1, the output voltage is 0. At time interval 1, the voltage across the capacitor input voltage is series 8 and the result of the negative 50 volts appearing on the output. But at the time of the diode reverse bias does not conduct with the because of the side of the resistor capacitor discharge of the 2 volts and with approximately 23 volts for the time interval 1 to 2. For the using the curve shuffle voltage determine the voltage of the circuit with the time of the output voltage decrease to 50 volts and 48 volts for time interval 2. 25 volts input signal to 23 volts across capacitor 1 series opposed the output voltage for the negative positive plus 2 valve of the anode of the diode 1 positive with respect with the cathode diode 1 will conduct the time interval 2 to 3 capacitor recharge quickly with the 23 to 25 volts through the diode 1 same time of the output voltage falls from positive 2 volts to the 0 volts. At time interval 3, the input for the capacitor voltage for the series the angle of the total output voltage for the negative 50 volt for the time interval 3 to 4 for the diode 1, the reverse bias of the capacitor, discharge of the resistor for the capacitor circuit operation now the same as the time interval 1 to 2. Circuit operation found in the square wave cycle with a duplicate for the operation will occur with the time interval 1 to 3, with some case for the positive clamper amplitude with the wave shape of the output with the almost identical to that in the input. However, the note the upper extremity output wave shape is clamped at 0 volts. This output wave shape for all practical purposes lies entirely below the 0 volt reference level. Or your negative diode clamper with the negative bias. With the VUA with the figure 422, with the circuit of the negative clamper with the negative bias again with the no input signal with the capacitor charge of the battery voltage with the output, the negative between the positive side of the battery with the ground with the bottom of the U. B, show the output with the circuit side with the figure curvedly with the note of the following important parts. Peak-to-peak amplitude shape of the output wave for all the practical parts, same as for the input wave. The output wave is clamped at negative 10 volts, which is the value of the battery. Since the negative clamp of the upper extremity of the waveform, just at negative 10 volts reference line, the rest of it lies below the voltage level. Figure 422 A show the negative damper with the negative bias with the battery voltage negative 10 with the resistor 1 diode capacitor output. Also the input voltage negative damper to negative bias. Let's review the important parts of the circuit operation for the capacitor. Initially, travel with the negative 10 volts with no input with the signal applying with the Kirchhoff law. We'll find with the positive 20 volts input signal with the 10 volt battery with the errors. The series opposed with the series opposing forward bias of the diode 1 capacitor travel with the negative 35 volts. The output voltage with the equal to the sum of the capacitor voltage with the input voltage. The rest of the output voltage is the negative 10 volts. The wave shape is clamped with the negative 10 volts with the negative 25 volt input. The charge maintained across capacitor 1 input with the series with the 80 with the input provided with the negative 60 volt output with the capacitor 1 discharge with the just because of the next cycle begin with the income becomes positive with the positive 25 volts input signal approximately negative 23 volts. The cause charge remaining capacitor 1 forward by the diode 1 output will be clamped to the battery voltage. Capacitor 1 will quickly charge in the input signal level of the output voltage varies between 10 and 60 volts with the wave shape of this clamped to 10 volts. Or your negative clamper with a positive bias. View A figure 423 illustrates the circuit with a negative clamper with a positive bias, no input with a signal with a stick capacitor over the battery voltage output with the positive between the negative side of the battery and the ground with the output. But this illustrated with the bottom half of the view B with the study with the carefully with a note with the following important points: peak to peak amplitude shape of the output waveform for all particular purposes same as the input of the output wave is clamped with the 10 volts with the value of the battery. So the negative clamper of the cathode is at the ground on the top of the output wave at the touch of the 10 volt reference line. Figure 423 show the negative clamper with the positive bias. Figure 423B show the negative clamper with the positive bias. Let's go over the summary with the circuit operation. No input signal with the capacitor charge with the 10 volt with the 25 volt input signal with the 4 with the bias of the diode 1 with the 10 volt battery with the input here with the capacitor charge with the negative 15 volt with the capacitor remaining charge with for all practical purposes same with the discharge with the resistor 1 very large the almost negligible output voltage is equal to the algebraic sum of the capacitor voltage with the input voltage with the 25 volt input signal added to the 15 volt capacitor charge is provided with the positive 10 volt output with the 25 volt input with the time 1 and diode 1 reverse bias with the charge across the capacitor 1 adds input voltage to the provided negative 40 volt output the time from time 1 to time 2 the capacitor loses only a small portion of the discharge time 2 input signal of 25 volts input returns the 10 volt for the wave shape is negatively clamped to the 10 volt battery. We can say with the positive clamping except the wave shape of the above with the negative peak on the reference level of the negative clamping devices plants in places with the wave shape of the positive of the peak on the reference line. Alright, common base transistor clamper. Or your common base transistor clamper, simple as a double diode limiter with a figure 415, except for the addition of the transistor, the previous clamp with the clamp out, simple signal the reference within the transistor, common base clamper we want, clamp the amplitude of the input with no more than or less than a certain value of the output. We do not want the phase inversion out of in the output view A, figure 424. Show such a circle. The transistor does not apply with the input and the output, but it is not inverted. However, the two diodes circuit serve the clamp of the output between negative 2 volts and 8 volts, no matter what the varying input positive of the negative extremities. 424 shows the common base configuration of the clamper input, the 1 to 8 volt, the clamp between 2 volts and 8 volts, of the input with the emitter with the common in the base, the resistor 1, voltage current collector 12 volt, and battery 1, 2, and 3, 8 and 12, 8 and 2 volt, and the resistor 1, diode 1, diode 2. Common base configuration clamper. Look at look at the view with the B with the so you can with the input signal square volts pulse type of signal will vary for the amplitude with any of the input signal with the transistor 1 combined conducts and provide with the current with the resistor 1 of the develop the output with the collector with the ground potential, which is assumed with approximately negative pulse voltage current collector with the voltage of the resistor 1 for this discussion. For time 0 to 1 with the output fall with the input that become the increase with the emitter base forward divide with the half of the time interval of the collector 1 collector voltage of the rate of the 2 volt with the diode 1 child 2 forward divide with the diode 2 conduct the limits of the output with the negative 2 volts. Value of the battery 3 with the diode 2 conduct until the time 2, but until when the battery increases below 2 volts. At the time when the diode 2 cuts off, the output again flows in the input because of the decreasing forward bias of the transistor 1. At time interval 3, the input reach of the 8 volts with the forward bias of the diode 1. Diode 1 conducts and any other further increase beyond 8 volts for the input. It has no effect on the output of the input. Return with the value more positive than 8, negative 8 volts. Diode 1 cuts off the output, again follows the input with the circuit action, same for all the input of the output remains same with the input except for the positives and negative extremities, clamped to negative 2 and 8 volts respectively. Alright, shaping circuit with the timing circuit with the circuit which requires a particular shape of the spike of the voltage may be used shaping the circuit with the shape of the circuit can be used with the wave shape of the square such as square wave, sawtooth with the wave, the tramps oil plate wave to change with their shape of the shaping circuit with maybe either the receiver of the RC or receiver of the RL circuit. Time constant is control with respect to the duration amplified waveform. Note of the wave shape dimension, but they do not include the sim wave of the RC or RL shaping circuit that do not change with the shape of the pure sim wave. The series of the RC RL circuits electronically perform mathematical operation. The integration with the differentiation there is the circuit that you perform the operation called the integrated differentiator. They are applied with the circuit that even though they do not always completely perform the operation of mathematical integration differentiation. Composition of the non-cyclic wave, the pure sim wave, the basic wave shape of from which for the other wave shape could be constructed any wave that is not pure sim wave, the constant if the two more sim wave, the adding of the correct frequency of the proper wave, the amplitude with the square wave, the sawtooth wave, and other non-cyclic waveforms. A waveform other than the sim wave is called the complex wave of the wheel C, with the complex wave with the fundamental frequency plus one or more of the harmonic frequencies, the shape of the non-cyclical wave frame, and dependent on the type of the harmonic present as part of the waveforms. They are relatively amplitude, relatively phase relations, but the general with the steeper side of the waveform that moves more rapidly with the rise of the flow with the more harmonic. It contains the sim wave that which have the lowest frequency complex the periodic wave with referred to with the fundamental frequency type of the number of the harmonics included with the waveform depending upon the wave shape of the waveform. The harmonics have the two classification, even numbered and odd numbered. Harmonics are always the whole number of the type of the higher than the fundamental frequencies and are designed to integrate the whole number. For example, the frequency twice as high of the fundamental frequency of the second harmonic with the first even harmonic. View A, figure 425 is compared with the square wave with the sim wave K is the same with the frequency with the square wave, fundamental frequency in other ways, sim wave L, the same smaller amplitude with the three times the frequency referred to the third harmonic is added with the sim wave K with the curve M is produced with additional with the two wave that accomplished without adding the instantaneous values. Both sim wave algebraically, curve M is called the resultant. Note for the curve M begin with assume the shape of the curve wave, the curve M is shown in view B. Alright, show square bit wave, L and K and M. K is the fundamental, the L is the third harmonic, M is the fundamental plus with the third harmonic, 5 and N is the fifth harmonic, Q is the fundamental with the third and fifth harmonics, Q is the seventh harmonic, and R is the fundamental with the third, fifth, and seventh harmonic. It's shown in view B with the figure fifth harmonic with the curve of the decrease of the amplitude with the added the side with the new resist with the curve of the P with the C with the before with the U C with the addition with the seventh harmonic with the curve of Q with the which is even smaller with the amplitude make the size of the composite waveform that still C in addition the more odd harmonics will bring the composite waveform neither the shape of the perfect square wave. Perfect square wave is therefore composed of the infinite number of odd harmonics with the composition square level of the odd all the odd harmonics are crossly reference lines of the phase with the fundamental with fundamental. Sawtooth wave shown in figure 426 many of the both the even hard and odd harmonics. Note that they each harmonic is added with a phase across zero reference view A, view B, view C, and view D. Resonant shown view and D with closely resemble the sawtooth waveform. Resonant fundamental second harmonic. Figure 426 A show the composition sawtooth wave. Your composition sawtooth wave resonant fundamental plus second harmonic, third harmonic. Alright, figure 426 6. This was composition, sawtooth wave, fundamental play for the second and third harmonics, fourth harmonics. Alright, 426D, show for the composition, sawtooth wave, result in fundamental plus second and third, fourth harmonics, time interval, fifth harmonic, and sawtooth. 427 show for the composition for the peak that when we wave notice for the how in addition with each for the each odd harmonic makes the peak of the resonant higher with the side steep of the phase. The relation between the harmonics peak of the wave with the different with the phase relation with the harmonic composition square wave and the composition for the square wave, the odd harmonics are crossed with the reference line with the phase of the fundamental peak wave with the harmonics such as the third, seventh, and so forth. Reference lines of 180 degrees out of fundamental within fundamental fifth and ninth and fourth is crossed with the reference line of the fundamental. Alright, A is your fundamental, B for the third harmonic, C for the fundamental play for the third harmonic, D the fifth harmonic, E the fundamental play for the third and fifth harmonics, F seventh harmonic, G fundamental with the play for the third, fifth, and seventh harmonica. Alright, non-inside voltage applied with the RC theory. The harmonic concept of the square wave must be complete with the produce of the pure square wave. This is harmonic square wave, not properly be the proper wave. The amplitude relation with the square wave will not be pure. In turn, pure is applied with the square wave, meaning the waveform must be perfectly square. Figure 428 shows the pure square wave applied with the shear of the resistive curve of the value of the two resistors equal the voltage available to each the resistor will equal from one pair of the square wave input with the two pure square wave. The lower amplitude will produce the value of the resistor does not affect the phase of the relationship amplitude relation harmonic contained within the square of the wave. The true peak of the same in the opposition inferred with the resistor of the harmonic present within. However, the same square wave was applied with the series of the RC circuit shown in figure 429, but the circuit again actually is not the same. Figure 428 shows the square wave applied with the resistor circuit. Figure 429 shows the square wave applied with the resistor circuit. Alright, RC integrators. We're going to cut the tape there because it's raining and I've lost the tape once already.